All right, so let's try implementing this depth first search pre-order. So we're going to go over here. I'm going to define the function. I'll just call it DFS pre-order like this. And then inside of here, I'm going to start by making our variable data that will return at the very end. So I could actually go down to the very end and return data. This is just the order that we're visiting the nodes. Then we'll make our variable called current and set it to be the root. Just like that. Now for the trickier part. Write a helper function, we'll call it traverse, that accepts a node. So I'm just going to do that actually nested inside of here. Function traverse accepts a node. And the first thing that we do is push the value of the node to our variable data. So we'll do data.push node. Then we check if there's a left property. If there is, we call the helper function with the left property, and we do the same for the right. So we could just do if node.left. What are we going to do? We're going to call traverse node.left. So this is traverse, we're recursively calling it. And we do the same thing if node.right, traverse node.right. And that's actually it for our solution. Except, well, that's a lie. We have to actually invoke traverse, which is what I talked about down here. Invoke the helper function with the current variable. So that's traverse and current, which is the root. And actually, we honestly don't even need this current variable. You could just do traverse this dot root. But what setting a current variable allows you to do, a user could specify a node to start from. They may not want to traverse from the root if you have a massive tree. I'll just do this though, this dot root. Okay, so if we actually run this right now with this tree, 10, 6, 15, 3, 8, 20. Let me just save this, execute it. Let's see if it works. Oh, you know what? I'm realizing it's easier again to push the value instead of the entire node. So let's try rerunning it one more time. Tree.dfs pre-order. Here's what we end up with. 10, 6, 3, 8, 15, 20. And that is the correct depth first search pre-order. So now let's get to the harder part, which is explaining how the heck that works. So I'm going to come down here and do a tree.dfs pre-order and add a breakpoint there. Now let's step through what happens when I execute this code. Okay. So I'm going to go to the call stack and step through this. Very first thing, we make our array called data. We call traverse on the root. Okay, now if we look at the call stack, we now have a traverse call, and we're pushing 10 into our array that we're returning called data. So 10 is in there. Then we check if there's a left, and there is. So we call traverse on the left, and that left node is 6. So we end up with another call added to the stack, this time on 6. And so we now push 6 into our array. So our data array has 10 and then 6. And we check, is there a left on 6? Yes, there is. So then we traverse node.left, which is 3. And so we end up with another call added on top. Now we're working with 3. Data.push node.value. So we add 3 into our list. So we have 10, 6, now 3 is in that data. And we check, is there node.left? No, there is not. So we don't traverse node.left. Is there a node.right? Nope, there's not. So we don't traverse that either, which means we're done with this call with 3. So you'll watch it actually pop off here. There we go. And now we go back to where we were on 6. Because 6, we stopped at this line, right? We're waiting for this traverse to finish. Now we get to the right. Is there a right side? Yes, there is. So that is 8. So now we traverse 8. So we add one more call right there to traverse. Data.push node.value, which is 8. So now we have 10, 6, 3, 8. Then we check, is there a left? There's not. Is there a right? There's not. So we're done. I'll click a few times, and it gets popped off. There we go. Now we're back to 6 at the end because this finished. We traversed the right side of 6. We did the left, then the right. There's nothing there. So we're done. with 6, now we're back to 10. So we did the entire left side of 10. Now we're going to do the right side. So the way that this works is that we visit a node, and then we traverse the entire left side, and then traverse the entire right side. That's sort of the high-level overview. But the way recursively it works, it can be a little tricky to step through. So now we're on 10. We finished pushing in for 10. That was very easy. We've traversed the entire left. Now we have to traverse the right. So is there a right? Yes, 15. So we traverse 15. So we get a call added to our call stack. For 15, we push 15 into our list. So now the list is 10, 6, 3, 8, 15. And we check, is there a left? There is not a left for 15. So we go to the next line. Is there a right? And there is, which is 20. So we traverse 20. And traversing 20 really just involves, you can see the call being added over here, data.push 20. So we add 20 in, and we've now visited every node. We don't actually know that until node.left, so this is going to be false. There's no left, there's no right. So 20 gets popped off the call stack, and then the call for 15 gets popped off, and then the call for 10, the original one, is popped off, and we finished all traverses. So this is the line that caused all that trouble, and this is what data now looks like. Now we just return data, and we're done. Well, there we go. Now we're done, and that's the order we visit things in. So to recap, what we do is recursively, we visit a node, then we visit the entire left side, and then the entire right side. So this order is really significant. And you'll see in the next 2 videos, or next 2 solutions, for different orders, all we have to do is tweak the order that this happens in. Okay, so that's coming up next.